Hello, welcome to the third problem covered on page 389. And these can be done in a lot of different ways, but here we are going to look at a plane that is flying. One plane is flying from Charlotte to Los Angeles, and the other plane is flying from Los Angeles to Charlotte. Let's take a look. This is a classic algebra problem, and let's take a look at how systems of equations would be used to solve this. All right, so like we said, there's a traveler flying from Charlotte to Los Angeles, and at the same time, there's another traveler that flies from Los Angeles to Charlotte. Now, this is an important line, the next sentence here. The airspeed of each plane is the same. Okay, let me explain what that means. That means if both of these planes were flying in the air with zero wind, they would be going the exact same speed through the air. Okay? Now, in the air, we have variables that can speed up or slow down a plane, like the wind. Okay? Well, the ground speed then, notice the next sentence. The ground speed of the plane leaving Los Angeles is 550 miles per hour. It is flying with the wind at its back. So, in other words, even though its airspeed is the same as the other plane, it's actually moving along, uh, compared to the ground, it's moving at a speed of 550 miles per hour. But notice what happens in the next sentence. The other plane leaving Charlotte is traveling against the wind, and its ground speed is 495 miles per hour. So that means it's not covering as much ground as quickly because it's pushing against the wind as it flies. Okay, so we have airspeed, which is just the capability of the plane to fly through the air, its speed. And then we have ground speed, which basically is how fast it goes over the ground, kind of like what we're used to when we are driving in a car. So it says use a system of equations to calculate the airspeed in the planes of the wind. Now this is the third problem in the notes. It's on page 389. You'll notice mine's worded a little bit different because on page 389 they have a picture that I would encourage you to look at where all of this stuff was labeled, but I didn't put the picture in here. I just kind of copied the information you needed to know. I would encourage you to take a look at that picture on page 389. Okay, so what we have to do first of all is figure out how fast, what is the airspeed of this plane? Okay, so let's see what we need to know to do that. Let's start by solving or picking a couple of variables, and let's let A represent the airspeed of the plane. Okay, that's the airspeed of the plane. All right, and then let's let W equal the wind speed. These are the two things we're trying to solve for, so that would make sense that we would define our variables as such. A is the airspeed of the plane, and W is the wind speed. So this first plane that was going 550 miles per hour, well, think of it like this. If you take the airspeed of the plane, that's the capability of the plane to fly, and then you add on the speed of the wind, you get 550 miles per hour. Now, I don't know that it actually works exactly like that, but for the sake of this problem, we're just going to assume that you would take the airspeed plus the wind speed, and that would be it. I don't think it would be exactly that. It would speed it up. Wind at the plane's back would speed it up a little bit, but I don't think it would actually speed it up exactly the rate that the wind is going, but it would certainly give it a little push. Whereas the other airplane, let's take its airspeed, and we're going to subtract the wind speed because it is flying against the wind at a rate of 495 miles per hour relative to the wind. So the one on the left here, that's the plane leaving Los Angeles. That's Los ANG is what that's supposed to be. And this is the plane that is leaving Charlotte. Okay, well, when I look at these two equations, if we solve these now, we can calculate approximately the average airspeed and the average wind speed. And by the way, as we say this stuff, we are talking about the average rates and the average speeds of the air and the wind because it's changing, it's speeding up and slowing down all the time. We're just saying an average over a period of time here. Well, looking at these two, I notice that this is plus W and this is minus W. So a really easy way to solve this um, particular system would be to use elimination like we learned this week. Eliminate. Because look what happens if I go A plus W equals 550. All right, and the other equation is A minus W equals 495. Give myself a little bit of room here. Draw a line. And let's eliminate. A plus A is 2A. That W minus W is gone. And then I add straight down here. And I get 1,045 as I add. All right, let's divide that by 2. Solve for the A. And we get A is approximately 522.5 miles per hour is the plane speed. And then let's take that and let's solve for one of the other variables, or the other variable, which is W. So I will substitute it. I'm going to substitute it into this equation because I think that would probably be the easiest. If I have 522.5 plus W equals 550. I'm going to subtract 522.5 from both sides, and we know how to do that. It comes out to be 27.5 is the average wind speed. All right, now these type of problems, there's a couple other types of problems that I'll probably show you later this week that have to do with rate and current and things, but that's a good place for us to start for this week. So get all those notes down and bring them to class, and be prepared to be working on these the rest of this week.